Welcome back, class. This is Mr. Neugebauer today. Go ahead and open up your books to page 347. This is lesson 9, qualitative graphs. Okay, so once again, page 247. Go ahead and open up your books. Pause if you need to get them out. Here we go. Right here at the start, it says, Emily is downloading photos for her, from her digital camera to her computer. The table shows the percent of photos downloaded for several seconds. So right here, we have seconds, we have time in seconds, going here by twos. Here we have the percentage download. Okay. Question 1 simply asks, during which periods of time did the percent download not change? So all we look at here is we see the percentage download. We notice here we have a 30 and a 30, meaning it stayed at 30% during this time frame. And now we're looking to stay during any other time frames, and then we see we have a 64, 64. So the percentages stayed the same here, stayed the same here. So during what time periods, and you have to be very clear on this when you're answering the question, so that you can't just say 4, 6, 8, and 10. Okay, that's not a good answer. Saying something like between 4 and 6 would be a good answer. And then saying and also or and between 8 and 10 would be a good answer. So it's very clear. You can see that these are two separate groupings, and that 4, 6, 8, and 10 were all the same percentage, but actually two different percentages that kind of were the same within that time period. Now looking at 2, it says during which period of time did the percent download change the most? So when did it actually change the most? Well, we see an increase of 15, 15, 0. Then we actually have an increase here of 34, 0. Then we have one of 18, and then we have one here of another 18. So our biggest increase is right here. So once again, you want to say this clearly. Don't just say 6 and 8. You would say increased the most between 6 and 8. Okay, so make sure you're answering these clear and neat. All right. Now it says on 3, graph and connect the ordered pairs. So once again, in a table, these are all x and y points. Okay, the point 0, 0 goes right here in the corner. Our next point is 2, 15, so forward 2, up 15. Then we have 4, 30, forward 4, up 30. Then we have 6, 30, so forward 6, up 30. 8, 64, so forward 8, up 64. 10, 64, forward 10, up 64. 12, 82, forward 12, up 82. And then 14, 100, forward 14, up 100. And we connect those. If you have a ruler or a straight edge, it'll look a little bit neater than mine, but you should have something like that. Now this graph is missing two very, very important things. The labels. Anytime you have a word problem that you graph, you should have labels, okay? So what's going along the bottom here is time in seconds. And then here we have percent download. Okay? So along the side we have the percentage download, okay? And that makes a great graph. So when you're graphing, remember those things. Now let's turn the page. Now, first vocab word here is qualitative graphs, okay? It says the graph shown is a qualitative graph. Qualitative graphs are graphs used to represent situations that may not have numerical values, meaning these are graphs that don't have numbers, or graphs in which the values simply are not given. Okay, so it's more of a general situation that you're graphing and have to think about rather than graphing specific points. Example here is the percentage download and time. If I took away all the numbers, it's going up, levels out, goes up, levels out, and goes up again with no actual numbers. Although it does look very similar to the graph we have right there on that page, okay? But now let's try to graph a few of these not using any numbers, okay? So here it says, the graph at the right displays the water level in a bathtub. Describe the change in the water level over time. So if we look at this graph here, we have water level on the side, time along the bottom. What's happening here is your water level basically first, when the tub's empty, starts 0, and then over time it increases at a steady rate. Okay, usually when you turn on the bathtub, you turn it on and you just kind of leave it on for a minute or two, while the tub fills up, and it fills up at pretty much a constant rate. You don't usually go around, hey, it's all the way on, partly on, more on, less on. You don't really mess with it. You just let the tub fill up. Then this flat part here, it's important you realize this flat part up here doesn't mean 0. It just means there's no change, okay? So basically what's happening here is the tub fills up, then time still increases. Time never stops, but the water level doesn't go any higher. This is basically when the person gets in the bathtub, takes their bath. The water level, there's still the same amount of water in the tub, but time is still going by. Then the person gets out of the tub basically, and then there is a decrease in the water level while it drains, okay? That's how you would graph this situation. So let's take a look at A here and try to describe this graph. It says, the graph at the right displays the temperature throughout the day. Describe the change in the temperature over time. So as we look here, it starts, colder in the morning. It kind of increases, but it's not really a constant increase. It's not a total straight line, it's curved. So what we would say there is it increases kind of at a varied rate, hits its peak or top, and then it decreases at a varied rate. So what you would say there is something clear and simple. We would say increases at varied rate, hits, that was its, forgot my H, hits its peak or top, hits it, I'll say top, then decreases at varied rate. Okay, that would be a great way to say that. And once again, I use the word varied rate because it's kind of a curve. It's not really a straight line. All right, let's look at B. It says the graph represents revenue from a local clothing store. Describe the sales over time. So here's time, and we don't know if this is hours, months, days. It really doesn't matter. We just see what's happening. Here's time, here's sales. So we notice sales go up. They kind of then peak and go down. They go up again. They go flat, and they go up again, okay? And in a situation like this, you may want to describe what's happening overall. So we'd say overall, sales increase but you would say sales increase, decrease, then increase again, and then you would say have no change, and then increase, something like that. So you're describing overall that it's going up and to the right, it's increasing, but then you're describing all of the change along the way, okay? Now let's look at here at example 2. It says qualitative graphs represent the essential elements of a situation. Basically, the essential elements are void of the numbers, but just have the labels like we have right here on the side. So this situation says a tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce. And that's normal with the tennis ball. You know, you bounce it from one height, and it slowly bounces less and less and less until it finally rests on the floor. It says sketch a qualitative graph to represent the situation. So you have to think first about your labels and put your labels on. Go distance from floor and time. Time is usually always along the bottom, so make sure you always put time on the bottom. And then right here we see our graph. You hold the tennis ball up. Don't start the tennis ball at the floor at 0. Just you hold the tennis ball up, and then you drop it, and then it goes up again, kind of at the same angle it went down, but you just don't go as high. Then it drops again, raises but not as high, drops again, raises not as high, drops again, raises not as high. Okay? So that's kind of how you would do that. Notice there's no numbers here. You're just thinking about the situation and how to graph it. The key for this one is recognizing when I drop the tennis ball, I'm not dropping it, I'm not starting down here at the origin, at the floor. I'm actually raising it up, and then it gets dropped. Okay, so you really have to be smart about how you're graphing these different situations. Now, let's see here. We'll do this. Final situation. It says a child swings on a swing. Sketch a qualitative graph to represent the situation. Once again, first thing you do is first thing you do is labels. There's no numbers, but you do need the labels. Time is along the bottom, distance from the ground is here. So the child starts on the swing, they're not sitting on the ground. They're actually raised up, sitting on the swing a couple feet off the ground. So then they swing, go a little bit higher, then come closer to the ground, swing up, come closer to the ground. Notice the ground level stays the same. The swing only goes so low. That ground level stays the same. You're still, about 3 feet off the ground the whole time. But as you swing, you can get higher and higher. Okay? So that would represent that situation. Now that was the final example. Now we just need to do this one together. It says, a car is traveling at a constant speed. The car slows down steadily to come to rest at a stoplight. Sketch a qualitative graph to represent the situation. Okay? So what we have here is I first need to make my labels. I have time along the bottom, and then it says the speed is along the side. Now I don't start down here at the origin. For this situation, it says nothing about the car speeding up from 0. It says a car is traveling at a constant rate of speed. So I already have the car traveling at a certain speed, maybe 35 miles an hour right there. Okay? And then the car steadily slows down. So that means it's going at not at a curve, but kind of at a straight line, going slower and slower over time until it comes to a complete rest at the stoplight right there. Notice now I'm at rest, so my speed's 0. As I'm slowing, time continues, time never stops, but my speed right there is 0. Okay, so that would be that situation. All right, if you have any questions, come to class tomorrow with your questions, and we'll practice this more.